Hello everyone. In this video, I will cover some stoichiometry problems. I will help you to solve from mass to mole, or from mole to mass, from number of molecules or atoms to mass, and then from mass to number of molecules or atoms. When you're given unknown, I'll show you, or when you're given a known, I'll show you how to solve for unknown. So before delving into the problems themselves, you really need to know what is given to you. So they need to give you some information. Is it given to you moles? Is it given to you a mass, a gram? Or is it given to you the number of molecules or the number of atoms? So they need to give you some information in the beginning. And then you need to know what you need to find, what you need to solve for. So this is kind of similar as the physics problem or the math problems. So you need to know what's known and you need to know what's unknown and what you need to find. For example, do you need to solve for moles, or do you need to solve for a mass, or you need to solve for a number of molecules or a number of atoms and some point. So that's what you need to really write it down. And I've written their templates. So you can use that template each time when you solve for any stoichiometry problems. Let's take a look at this first problem. So it says when 25 grams of calcium carbonate decomposes completely, how many moles of CO2 or carbon dioxide are produced? So here, as you see, you are given 25 grams of calcium carbonate, so gram, and then you need to solve for moles, more correctly, the moles of CO2. And before, you need to balance the equation, but in this specific equation, you don't need to balance anything because everything is balanced for you. So that one that you see I wrote in blue, we typically don't write that one, but I just wrote in the first problems just so visually you could see that they're actually 1 moles, but in fact we don't write it. And here is the template that I was talking about. So you have given, find, ratio, and what's under the standard condition. So given, what's given to you? So as you see here, you are given 25 grams of calcium carbonate. What do you need to find? You need to find the moles of CO2. It's not moles of calcium carbonate, but you need to solve for moles of carbonate. The carbon dioxide. And then the ratio. As you see here, the ratio from calcium carbonate to CO2 is 1 to 1. That's what they say, 1 mole to 1 mole. So you just write 1 to 1 in ratio. And then the final one is the standard condition. And that's what you need to also know. So under standard condition, we know that the molar mass of calcium carbonate is around 100 gram per mole. So also we can write it as 100 gram per 1 mole. So it's 100 gram of calcium carbonate per 1 mole of calcium carbonate, and that's what we call a standard condition. So we have that gram of calcium carbonate, 25 gram, so that's why we need its molar mass as well. And you can find that molar mass information on periodic table. All right, let's go ahead and solve it. So first, what you need to write the given, the noun. It's 25 gram of calcium carbonate. That's why it's very important to write that table. So, and then you write the next thing, of course, the standard condition. You see there, under the standard condition, there is 100 gram of calcium carbonate per 1 mole. And you write 1 mole on top, and then you write 100 gram on the bottom. And so why we need to write in this specific order, I will explain you in a minute. But we need that for canceling the units. And then the third one you write is the ratio, of course. So it's a 1 mole of calcium carbonate per 1 mole of CO2. And then you write the CO2 on top and calcium carbonate, 1 mole of calcium carbonate on the bottom. and you know that from the balancing. Okay, so now first what we do is we do need to cancel those units. So we have given, and you will see now how did I write in this specific order here. So first thing what you do is you need to make sure the units will be canceled. Like if there are same units on top and bottom, that's what you need to cancel them. So it's basically what you do in the fraction. So let's say you have gram of calcium carbonate on top, you have gram of calcium carbonate on the bottom. That's what they cancel out. Same moles of calcium carbonate and moles of calcium carbonate on the bottom. That's why you should make sure you write them in the correct order. Which one goes on top, which one goes on the bottom. That will determine the cancellation. The rest is just the math, but you may probably already know, but I'll just go ahead and write it down. So you just write the numbers, 25 gram times 1 mole, and times 1 divided by 1000. And here I'm just showing with arrow where did I get those numbers. So 1, 1, and then the 1 also, the CO2, and on the bottom is 100 gram. And there should be times 1 as well. I apologize, I forgot to write that 1 denominator. So when you do that, you get 0.25. And the unit will be, of course, the moles of CO2. So make sure you write down everything. Don't just write mole. It's a mole of CO2. Because there's also mole of calcium carbonate. So, and you need to read carefully what you need to solve for. In this specific problem, you need to solve for mole of calcium carbonate. The next problem is, so if 17 gram of H2O2 decomposes completely, how many moles of O2 are produced? So again, you have been given gram, and you need to solve for the moles. And as you see here, we need to first balance it, and this one is not balanced, this equation. So I put 2 and 2 in front of H2O2 and H2O. The next is just filling those, the template. What's given to you? Again, it's 17 gram of H2O2. That's what given. And the next one is, of course, what you need to solve for, what you need to find. You need to find how many moles of O2 are produced. So it's gram to mole. And again, you need to write the ratio. It's 2 to 1. So you write 2 1, and then on the bottom is again under the standard condition. And since you are given 17 gram of H2O2, you need to make sure you convert that gram to mole. And for that, you need to know the molar mass of that H2O2. So that's why you write the molar mass of H2O2 is around 34 gram per mole, also known as 34 gram per 1 mole. 34 gram of H2O2 per 1 mole of H2O2. And make sure you understand the concept of that. And it's under standard condition. It's 34. How do I get it? It's from the periodic table. And you'll be provided the periodic table. All right. The next is just solving the plugin. The first, again, you need to write what's given to you, which is 17 gram of H2O2. Again, I would write it down everything. So make sure that during the canceling units, you do it correctly. So the next is you write the standard condition, because you need to convert that gram to mole. So you write 1 mole of H2O2 on the top, and then you write 34 gram H2O2 on the bottom. Again, the order really matters. You make sure your gram and gram cancels each other, or gram of H2O2 and gram of H2O2. The next is, of course, you write the ratio, which is 2 to 1. And here is Also make sure you write it correctly. So 2 moles on the top. Why? Because it's a two moles of I apologize, it should be 1 mole. Yeah, it's a 1 mole of O2 per 2 moles of H2O2. Why? Because you need to cancel those moles, because you have there 1 mole of H2O2 that should cancel to 2 mole of H2O2 on the bottom. So let's first make sure we correctly cancel all the units, and then we should be left with moles of O2. That's what we need to solve for. And here, as you see, all the units are cancelled, and then only mole of O2 is left. So the rest is just the math. The 17 times 1 times 1 divided by 34 times 2. So, and I do show the where those numbers came from with arrows, but I apologize if it's too simple, or if I'm going like too much detail. So I just want to make sure that everyone understands where those number came from, because they are very, very important. And then you multiply and divide. It's just a normal math. And when you do that, you should be able to get 0.25 mole of O2. Again, make sure what unit is left. It's a mole of O2 is left, and that's what you're gonna have in your as a final unit. Units are very, very, very important in stoichiometry. All right, next problem is if 9.8 gram of NaOH reacts completely with excess H2SO4, how many moles of H2O are produced? So again, so you are given here a gram. You need to convert to mole. So it's a gram to mole, just like the previous two examples or two problems that I showed. Again, first you need to do is the balancing. Make sure that the reaction is balanced. And then the rest is just filling the table. What's given to you, it's 9.8 gram of NaOH. So you write it down, and make sure you write down also units. And then what need to find is, of course, the mole of H2O, or moles of water. Ratio between NaOH and water is 2 to 2. But we can write it also as a 1 to 1. We just divide both sides by 2. You should be able to get 1 to 1. Just make sure we simplify it. But even if you write just 2 to 2, it won't still matter, because you need to just divide it to each other, and it's going to be 1. And then the final one is, of course, the standard condition. And again, if we have 9.8 gram of NaOH, you need to make sure we convert this 9.8 gram to mole, and for that you need a molar mass. So the molar mass of NaOH is roughly around 40 gram per mole, and so known as it's a 40 gram per 1 mole, or 40 gram of NaOH, or sodium hydroxide per 1 mole of sodium hydroxide. So now we have all the units, and the template is filled, and we can go ahead and solve for the unknown. So first you need to write the given, what's given to you. It's 9.8 gram of NaOH. So first of all, you write that given number, and of course you need to write the unit as well. And once you write the unit, then you second you write the standard condition. What's on the standard condition? It's 1 mole of sodium hydroxide, or NaOH, is per 40 gram. So 40 gram per 1 mole. And sorry, I forgot to write NaOH on top, and here I'm going to write it now. and then the rest is the next one is the ratio. You need to write it down, and it's 1 to 1. Again, you can write there 2 to 2, but it won't matter because the division will get you only also 1. And it's very important to write the correct units, the mole of NaOH and the mole of H2O, and just to make sure that they cancel. NaOH especially, it needs to cancel. And before solving for the problems, you need to make sure you cancel out. So gram of NaOH, mole of NaOH, mole of NaOH, they're all gone. And then the final answer will be what's left, which is mole of H2O. So again, you write the numbers now, solve for numbers, because you cancel the units, not the numbers. Numbers you still need to solve it. So I just plugged those numbers, and here I'm writing with pointing with arrows where I got those numbers from. So I apologize if they're too simple. I just make sure that everyone understands. So with that, you solve for it, and then it's gonna give you again point 24 or 0.245. The unit is of course a mole of H2O, and read on the top. It also says how many moles of H2O are produced, and then for the answer is of course 0.245 mole of H2O was produced. Alright, the next problem is if 1.5 or 1.50 mole of Na or sodium reacts with excess Cl or Cl2, what mass of sodium chloride is produced? And now you have given a mole, 1.50 mole, and you need to solve for gram. But make sure you do it correctly, because it goes from mole of sodium to gram of sodium chloride. You need to find what's given to you, write it down. So 1.50, and always write the units. So 1.0 mole of sodium or Na. And then of course you need to find for the mass of sodium chloride. And you write for that, or gram of sodium chloride, and then you need to make sure you know the ratio. It's 2 to 2, and which is when we divide both side by 2, it's going to be 1 to 1. And then finally you need to write the standard condition. So under standard condition, so what you need to do, we need to find the mass of sodium chloride. That's why we need to make sure that we know the molar mass of sodium chloride as well. And then under standard condition, molar mass of sodium chloride is 58.44 gram per mole, or also we can say it as 58.44 gram per 1 mole of sodium chloride. And how do you know those numbers? So it's on the periodic table. So since we have everything now, so we can just go ahead and plug the numbers. And first thing first, you need to write the given. What's given to you? It's a 1.5 mole of sodium. So I'll go ahead and write 1.5 mole of sodium. And when you do it, make sure you write the units as well, not just the number. And then the rest is, again, you need to write some standard condition. And the standard condition, it is 58.44 gram of sodium chloride per 1 mole of sodium chloride as well. So in this scenario, and make sure that the units should correctly cancel each other. And then the next one is, of course, you write the ratio. It's 1 to 1, 1 mole of sodium chloride to 1 mole of sodium. And even though it's written 2 to 2, you can simplify it by dividing both sides into, but even if you put 2 there, then you should still be getting the same answer. So it's a 1 mole of sodium chloride per I apologize, it should be oh yeah, 1 mole of sodium chloride per 1 mole of sodium. Yeah, that's correct. Apologize. So first thing, what we need to do before solving for numbers, we need to make sure we cancel each unit that needs to be cancelled, starting from mole of sodium, sodium, and then the mole of sodium chloride. The only thing is left is gram of sodium chloride, and then the final answer unit would be, of course, the gram of sodium chloride, because if you read top, it's written what mass of sodium chloride is produced, and mass it, of course, the gram. And so you just plug the numbers here, because you can cancel the units, but you cannot cancel the numbers. For numbers, you need to solve it. And here I'm writing, explaining them on with arrows. So where did I get 1.5? Where did I get 58.44? And where did I get 1 again at the end, top end? And then on the bottom, you need to make sure you also write the unit. So it's a 1 mole times 1 mole. And when you solve for it, you should be able to get 87.66. And now it's gram, because pay attention, the only unit that didn't cancel is a gram. So then your answer will be 87.66 gram of sodium chloride, because that's what you need to find, the gram mass of sodium chloride. The next problem is if 0.800 mole of KClO3 decomposes completely, what the mass of oxygen or O2 is produced. Again, you're given the mole, and you need to solve for a mass. So it's a mole to mass, or mole to gram. First, what you need to do is, of course, you need to balance the equation. And here I did balance, so it's 2, 2, and 3. That's what I put. It's the mole of each of these molecules. And then next we have this template, and you need to fill the template. And when you do, make sure you write all the units correctly, not just the numbers. The first is given, and you need to find, you need to write down what's given to you, which is 0.800 mole of KClO3. The next one is, of course, you need to find what you need to find. You need to write it down. So which is a gram of O2, or the mass of O2. And then the next is the ratio of KClO3 to O2. It's 2 to 3, and you need to write down here. And then the last one is the standard condition. Since you need to find the gram of oxygen is produced, you need to find what's the under standard condition, what's the molar mass, or gram per mole of oxygen. The molar mass of oxygen under standard condition is 32 gram per mole. 32.01 gram per mole. Or also you can say it as 32.01 gram per 1 mole. It's under standard condition. I apologize for the mistake. So since now we have everything ready, we have written, we have filled the template. The next is, of course, we move to solve the equation, to solve the problem. And you need to write this, the fraction line. And then the first thing first, you always make sure you write your what's given to you. The rest is the order doesn't matter, but the first one is always should be the given, which is 0.800 mole KClO3. And then so the next thing, you can write the ratio there, or you can even write the standard condition, doesn't matter the order. I'm gonna go ahead and write the ratio. So it's 3 to 2. You make sure you don't mix the order. It's 3 should be on the top, 2 should be on the bottom. Why? Because we need to make sure that the mole of KClO3 will cancel out, and it's the only setup we can cancel out the mole. And then the last you can write the molar mass, which is 32 gram or 32.01 gram per 1 mole of oxygen. So this is the molar mass of oxygen under standard condition. You're not asking the molar mass of KClO3. That's going to be a little different, but we don't need that because we already have the mole of KClO3. And here, make sure you write that in the order based, because the O2, the oxygen and oxygen should cancel out. That's why you write 32 on the top and 1 on the bottom. And when you cancel out, here you see all those units will be canceled out, but not the numbers, of course. The numbers you need to solve. And then your final answer will be the gram per O2. Gram of O2. So you may already know how to solve this, but I just want to write it down. You write all the numerators, and then on the bottom just denominators. And again, here I'm gonna show with the arrow where I got those each numbers: 0.8, 3, 32.01, and then 2, and then 1. So when we do the calculation, then we should be able to get 38.40 or 38.4, and that should go on the last, since don't have enough space there. I'm gonna write it the unit on the bottom, 38.4. It's a gram of O2. The next question is, if 0.20 mole of H2 reacts completely with excess oxygen, how many molecules of water or H2O is that? So now you have been given mole, and now you have to solve for the number of molecules. Now, not for gram, not for mole, but now you need to solve for the number of molecules. And the standard condition will change here. Okay, let's go ahead and start with the balancing the equation. Make sure we have 2 in front of H2 and H2O. And then the next is we need to fill our template again. What's given is 0.2 mole of H2. Make sure you write the H2 as well. And then we need to find is the number of molecules of H2O. So you are given the mole of hydrogen. You need to solve for the molecules of the water. And then the hydrogen to water ratio is 2:2, and we can simplify it and just write 1:1. Just for simplicity, you can write 2:2 anyways, because one will go in the numerator, one will go in denominator. And then under standard condition here, you need to find the number of molecules of H2O. So the standard condition will change here. Now you don't need molar mass, but you need the number of molecules in 1 mole of H2O. So in 1 mole of water or 1 mole of H2O, there are 6.022 times 10 to the 23 molecules of water. That's also called Avogadro's number. Any molecule in 1 mole of water, hydrogen, oxygen, nitrogen, anything, it contains that amount of 6.022 times 10 to the 23 number of molecules. And now we have everything. We can go ahead and start plugging in. So first, as always, you need to write what's given to you. That's how you start. So 0.20 moles of hydrogen. And then the next, you need to write the ratio. Again, the order doesn't matter. It's for more like simplicity. So the 1 mole of H2O per 1 mole of H2, or 2 mole per H2O, 2 mole of H2. And make sure you write H2 on the bottom because that needs to cancel. This third one you need to write is, of course, your standards, which is that number, the Avogadro's number, or an Avogadro. That's the number of molecules. It's going to be per 1 mole of water. And make sure you also write the waters, the symbol as well. Okay. And again, 1 mole should be on the bottom because the 1 mole of H2O should cancel with 1 mole of H2O on the numerator on the previous section. And then so we're gonna go ahead and cancel all the units. And then what we have ended up with was the number of molecules. Again, we're gonna go ahead and solve for it because the units cancel but not the numbers. So 0.2, 1, and then the Avogadro's number divided by 1 times 1. And I apologize if I'm oversimplifying it. Just want to make sure everyone understands where those numbers they came from in the fraction. And when we go ahead and solve it, we should be able to get it should be 1.2044 times 10 to the 23. That's the number of molecules of water. Make sure you write the final unit also correctly, because if you read in the top, you need to find the number of moles of water, and that's how we find. The next question is, if 0.75 mole of aluminum reacts completely, how many oxygen atoms are contained in the aluminum 2SO4 3 produced? So now you have been given mole and you need to find the number of atoms of oxygen, not the whole number of molecules of aluminum or aluminum 2 aluminum sulfate, but the number of moles or number of atoms within that molecule. And this might be a little bit tricky because you need to make sure you write the correct the moles, the number of oxygen. So given, again, the given is 0.75 moles of aluminum, and then again you need to solve for the number of oxygen atoms. And now if we just take the ratio, and this one is more very important. Oh, again, we need to first make sure we balance it. So the ratio of aluminum to aluminum sulfate is 2:1. This is the ratio between two molecules, but remember, we need to solve for the number of oxygen atoms, not the whole molecule. So here I wrote it down. You should also know the ratio of this oxygen, just the oxygen atom inside within this aluminum sulfate, or aluminum 2SO4 3. What is the ratio? How many moles of oxygen does this whole molecule contain? Because again, you need to solve for the number of atoms now. This one is a little bit trickier than the previous question. So as you see here, it's 12:1. 12 where I got, it's 4 times 3. That's gonna give you 12. It's a mole of oxygen within that the huge molecule. So now we know the ratio between oxygen and the whole entire aluminum sulfate molecule. It's 12:1. This is the additional thing you need to do if they ask you the number of atoms inside that molecule, not the molecule itself. So we're gonna go ahead and write the standard condition again. Um, the There are 6.022 times 10 to the 23 atoms um, of oxygen inside the per 1 mole of oxygen. So this is just under standard condition, and that's the number called N Avogadro, or Avogadro's number. Okay, now we have everything. We're just gonna plug in all our numbers. As usual, you first write the given um, the number. It's 0.75 mole of aluminum. Make sure you write the unit. Now second, you write the ratio of aluminum to aluminum sulfate. Now it's a 2-to-1 ratio. Um, aluminum sulfate should go on top and aluminum should come on the bottom. Um, Make sure you don't switch the place, because you need to cancel that mole of aluminum. And then the second one you write, the next one you write the mole ratio of oxygen and aluminum sulfate, which is 12 moles of oxygen. Why did I get 12? Because that 4 times 3 gives you 12 per 1 mole of the aluminum SO4 or aluminum sulfate. So it's a 12-to-1 ratio. That's the additional thing that you need to do when they ask you to solve for number of atoms. And then the last one, of course, you write your standards there. Since you need to find the number of atoms of oxygen, you need to make sure what's the standard condition, how many number of atoms of oxygen you have per 1 mole of oxygen. The standard condition, but now you need to solve for 12 moles of oxygen. But per 1 mole, you need to know that it's this Avogadro's number, 6.022 times 10 to the 23. And I apologize for a little mess there. So you need to make sure you cancel all the units, everything, and then all you have left is the number of oxygen atoms. And then you do the math. Remember, units cancel out, but not the numbers. So I'm just gonna go ahead and write 0.75 times 1 times 12 times 6.022 times 10 to the 23 divided by 2 times 1 times 1. I'm just gonna quickly show where did I get those number. Where did I get those number? I apologize for the oversimplicity, but I need to make sure everyone understand, especially if you have watched my previous videos. These are where I got put those numbers. So it's just a fraction, and then you just solve for them, and when you calculate the top and divide it by the bottom, you should be able to get 2.71 times 10 to the 24, the number of atoms, number of oxygen atoms that you have per 12 moles of oxygen. So this is going to be the final unit. Let's take a look at the next question. So now it says if you start with 1.2 times 10 to the 23 hydrogen atoms, not the molecule, atoms, and they completely react with the chloride, how many moles of HCl can be produced? Now you have the number of atoms of hydrogen, and you need to solve for the moles of HCl. So this one also can be a little bit trickier, because they're not asking you the number of the molecules, but the atoms. And we have start from, of course, the balancing the equation. That's pretty easy. And then we're going to fill the template. So it's 1.20 times 10 to the 23 H atoms, what's given to you. And then what you need to find is the moles of hydrogen chloride, or HCl. And then the ratio it's a little bit tricky. So you may say it is 1 to 2, but it's not. It's 2 to 2. Because, why is that? Because you have two mole, you have, yeah, one mole, but you need to find the H atoms, or you have given that H atoms. So now, so you need to find you need to make sure you write the two, because you have two H atoms per molecule. That's why you write two there, and this is one of those exceptions. So that's why you write two. It's a 2 to 2. We can also write it as a 1 to 1 mole ratio, just for simplicity. So if you're given the number of atoms, you need to make sure, if you have a single atoms, you write that 2, because there are 2 atoms per molecule. So under standard condition, we write, of course, the n Avogadro. So now there are 6.022 times 10 to the 23 H atoms. So it's under standard condition that much H atoms you have per 1 mole of hydrogen. So that's under standard condition. And you don't need a molar mass here, because you're just straightly going from hydrogen atoms to the moles of HCl. Okay? So we're gonna go ahead and compose our the the math, the solving. So first you need to write is, of course, the given. What's given is 1.20 times 10 to the 23, and there are H atoms. So go ahead and also write the units. And then the next thing you gonna write, of course, the ratio. So you need to write, I apologize, not the ratio, but the standard condition. So under standard condition, there for 1 mole of hydrogen, you need to solve for, there are 6.022 times 10 to the 23 H atoms. It's just the standard condition, and then you can write the ratio. And to be honest, the order doesn't matter. You can first write the ratio, which I've done in my previous. So as long as the units they cancel out, and then you'll have to end up with the unit that you need to solve for, the moles of HCl. That's what you should have at the end. Right, let's see if I wrote them correctly. So H atoms, they cancel, moles of H cancel, and then you have left with moles of HCl, and that's the most important, because make sure that that's the unit that you end up or left is the unit that you need to solve for, and it's a mole of HCl, not the mole of H2 or chlorine. It's HCl. So that's why it's very important to write down all the units. And then the rest is just the math. I just quickly point where they got those numbers from. In case if you haven't watched my previous videos, that's how we compose. It's all just a big fraction there. You multiply numerators and divide by denominators, and if you do that, you should be getting 0.199 moles of HCl. It's the mole of HCl that you need to solve for. Alright, the next question is, if 2.41 times 10 to the 24 molecules of carbon dioxide, CO2, are produced, then how many moles of C3H8 reacted? So now what you're given is the number of molecules of CO2, and you need to solve for the moles of it's called propane, C3H8. So first, of course, you balance it, and when you do that, the next is you fill the templates here. What's given to you is the first thing first, you need to write it down. It's 2.41 times 10 to the 24. So molecules of CO2. It's not the atoms, but now you have molecules. But sometimes they may give you find the number of oxygen atoms, and with that is gonna be a little bit different because you need to have extra step into make sure you write the ratio correctly. The second is you need to write what you need to write, what you need to find, which is moles of C3H8, and this one is pretty straightforward. It's just the ratio is 1 to 3. But again, if you need to find the oxygen atoms, then you need to do additional step of the ratio between oxygen atoms and CO2. And then the next thing is, of course, you need to solve for standard, write it down the standard condition. Since you are given the number of molecules of CO2, you need to write the under standard condition how many number of molecules you have per 1 mole of CO2. And it's the an Avogadro 6.022 times 10 to the 23 molecules you have per 1 mole of the carbon dioxide. So now, since we have everything there, we just plug in, and as always you write the given numbers there. The given is 2.41 times 10 to the 24 molecules of CO2 or CO2 molecules. Then you just split it, you make sure you divide it. The second one is you write the standard condition, and you can also write the ratio. It doesn't really matter, but for sure you write the in a correct setup, in a correct way that numerator and denominator can be cancelled, and it's a 1 mole of CO2 per the Avogadro's number molecule of CO2. So I wrote this in Avogadro on the bottom, because I need to make sure that the units are cancelled. I apologize. I first wrote the molecule of CO2, but I erased and I did CO2 molecules. And those CO2 molecules should cancel the numerator and denominator. The next you write, of course, the your ratio. That's all. The only thing is left. It's a 1 mole of the propane per 3 mole of the carbon dioxide that is generated. So you go ahead and cancel out all the units that you need to be canceled. So it's the CO2 molecule and then the moles. So always make sure you cancel the units before you solve for the numbers, and make sure you write them in the correct order. Which one goes top, which one goes bottom. That what defines what you need to find. So what's left, what unit you need to end up with, which is moles of C3H8. And next, all I'm doing is just I'm plugging in all those numbers. I apologize if I'm oversimplifying it, but if you're watching the first time, that's how we get these numbers from. I highly recommend you to watch my previous videos as well. I dropped the link below where I'm explaining all this, the theory behind the stoichiometry. In this particular video, I'm just writing down, doing some the problem solving. And so when you calculate, you should be able to get 1.33 moles of C3H8. Alright, the next problem is if you have 88 gram of C4H10, that's butane, and it reacts, and how many moles of carbon dioxide are produced. So now you have a gram, and you need to solve for the number of molecules, not the moles, number of molecules. So first you, of course, write what's given to you. In fact, you need to first balance it, but I'm going to do it in my next step. So it's given is 88 gram of butane, or C4H10, and then you need to solve for the number of molecules that are produced CO2, the number of molecules of CO2. And then the next one is the ratio, of course. And here I'm going to go ahead and balance the equation, the formula. You need to first always balance the formula, otherwise you don't know the actual ratio. So, and then the ratio is in fact 2 to 8 between butane and carbon dioxide. And when you simplify it, divide both sides by 2, you should be able to get 1 to 4. So, and then you write what you have under standard condition. So since you are given a gram of butane, you need to make sure you convert that gram to mole, and for that you need a molar mass. And under standard condition, so the molar mass of butane is 58.12 gram. That's the 58.12 gram of butane per 1 mole of butane, or C4H10. So the next thing, what you need to find is how many molecules of carbon dioxide produced. For that, you need to know under standard condition how many molecules of carbon dioxide you have per 1 mole of carbon dioxide. So you have the 6.022 times 10 to the 23 molecules of carbon dioxide per 1 mole of carbon dioxide. And remember, sometimes they may ask you the number of atoms, the oxygen atoms you need to solve within the carbon dioxide, and that's going to be a little bit different. You just have an additional step where you need to find the ratio between carbon dioxide and oxygen. Okay, so now we have all the parameters that fill our template, and we're going to go ahead and plug the numbers and units. The given will always comes first. It's 88, apologize for mistake, 88 gram of butane that you have, and then the next is, you can write it any order, the ratio or the standards. So I'm going to go ahead and write my standards next. All you need to pay attention is which one you're writing on top and which one you're writing on the bottom. And under standard condition, we know that so the molar mass of butane is 58.12 gram per 1 mole of butane, C4H10. And you write, make sure 58.2 is on the bottom because you need to cancel out those units. So the next you write your second standard under standard condition. I apologize. You can write the ratio as well. So again, the order doesn't matter. So it's 4 to 1, 4 moles of carbon dioxide per 1 mole of butane. That's the ratio reaction. I'm going to rewrite the CO2, I apologize. And then the next, you make sure you write the second standards. Under standard condition, you have that many molecules, the Avogadro's number of molecules per 1 mole of CO2. That's how much the molecule. And if you notice it, that's the standard. And in 1 mole of every molecule, every atom, you have that many number of molecules. And then we're going to go ahead and cancel the units. So the butane, the gram of butane, the mole of butane, they cancel out. And then, of course, the mole of carbon dioxide. And you end up with the number of CO2 molecules. So always solve for units first and make sure you cancel them correctly. Otherwise, one small mistake, the whole the equation will give you the wrong answer, even though you did everything correctly, but you only mixed one place, you put it wrongly in numerator and denominator, and that's just gonna get you a wrong answer. Especially if your test is multiple choice question, that may give you a wrong answer, even though you did everything correctly, but because of one small mistake, they may give you a wrong answer. And here, I just plug in everything, all the numbers, and I'm just quickly pointing out where I got from those numbers. We solve for units, and then we solve for now the numbers, and so just multiplying the numerators and divided by the denominators, and then when you do that, you should be able to get 3.65 times 10 to the 24 the molecules. This is the number of molecules you have, carbon dioxide molecules per that amount.